Is everyone back? Yes. Awesome. So you can start just with yours and I will be talking a bit on top. So welcome back. This is just, we're going to do a small change on the agenda. So basically, we know that a lot of you are a bit tired. This is a super dense amount of talks and it's a lot of different topics. So in around 2 talks, we are going to do again 10 minutes break so you can hydrate, straight back. I mean, I see that there are straight backs there. Awesome. You are doing my tips. With this said, take the last pictures. In this 10 minutes break, we are going to do the raffle for the 3 bags. So I'm hoping for good participation there. We already have quite some people using the hashtag. And nothing, the next person up is my colleague, Dan. He will be talking about how we build scalable components at Glovo. So big clap for Dan, please.
Hello, hello. So my name is Dan. I'm going to talk to you about building scalable components, multiple ways that we can build components and how we're doing it at Glovo. Obviously, I'm a software engineer at Glovo. That would be weird. I've been working on all big 3 frameworks. So I've started with Angular, then I moved to React, and now here at Glovo, we're using Vue exclusively across all our projects. I'm part of the first order experience team. Our initials are Fox. So we have this cute Fox logo that we use in all our channels. We are responsible for the new user's journey across the application. So users that don't have any habits formed and they see the website for the first time, we have to make sure they have a nice experience and we try to push them a little bit to the checkout as soon as possible. So I'm going to start with an introduction and then I'm going to talk about multiple patterns that we use. And then I'm going to finish up with an example of a recent code that we shipped, I think, a couple of months ago. So a little bit about Glovo. We're a delivery company. We focus mostly on food. It was founded 8 years ago here in Barcelona. So we're local. We operate right now in 25 countries. And tech-wise, we have multiple applications. So we have an app for couriers, we have an app for partners, we have an admin, a back office that multiple teams use, and then we have customer applications. The customer applications, we have one on iOS, one on Android, and the web. All 3 of them use the same API, so we have the same backend for all of them. And in total, they each bring like 70 million orders per month, give or take. If we're zooming on the web application, we have 6.57 monthly users. Out of these 7 million users, 55% are new. Every month, we get a batch of new users. So we have to exclusively focus on these type of users. Around 67% are on mobile, and the Chrome percentage is 60%. A fun fact, we have 200 people that order from their consoles every month. So their phone is just too far away when they're gaming and they just like, no, let's order from the browser. We have a total of 96 engineers contributing to the web application. About 40 of them are active and we do around 16 to 20 deploys per day. And I want to talk about 3 features that we use, methodologies, tools that we use to help us ship very good code and bug-free. The first one is A/B testing. Almost every feature that we ship is covered by an A/B test. We want to verify that our feature is working correctly for our user, that it moves the needle in the right direction. So for example, if we have a button that we added, a new button, we want to know that, hey, that button with we show a version of the code without that button and a version with the button. And we want to make sure that the version with the button is way, way better than the one without it. Oh, no. Whew. The second one is feature toggles. So for every little feature that we ship, we make sure we cover that code in an if statement. So if that feature toggle is turned on, then we show it to the user. This gives us a lot of flexibility. We can use it as a kill switch. If we ship code that is not working, it's breaking production, we can just turn that off in the admin and users are no longer seeing that feature. We can also use it for A/B testing. We use it for ourselves to test code in production. We just create a feature, we ship it, and then just turn it on for ourselves. So the users don't see it, just us. And this is very, very good. And another thing, like I was talking about the 200 people that are ordering from consoles, we always look for, we use observability to check critical business flows to see if everything is correctly working in the application. We have version history where we can see if an error was published, is appearing a new error in production. We know with which version of the CI/CD pipeline it appeared on, and we can just ask someone, hey, can you revert it? Or do a quick fix. So all of these three are essential for us to ship really, really good code at scale. So I'm going to start with the first pattern, the container presentational pattern. This is pretty well known. I think all of us use it. It's the most common pattern that we do when we write components. It has different names. Dan Abramov, the creator of Redux, called them the smart dump components pattern. And it's pretty basic in its, you create some components that have no logic. They are responsible just to present something to the screen. They emit events when acted upon, and they contain only presentational logic like styling. And they are decoupled from the rest of the application logic. Container, on the other hand, are responsible for the state of these components. They pass data to the dump components, and they listen for events. And here is where the entire logic happens. They can have multiple dump components as children, and they are responsible for the overall layout of the components. So this is a proper example from Glovo. In the homepage, we have this presentational component, this big container that has the title, the input, and the use current location button. All three of these are presentational components, and they emit events which the container listens for and acts what needs to be done. And the code starts very simple. So this is the first version of the code from before. This is it now. This was 2 years ago, I guess. And it starts simple and innocent. So we have only 33 lines of code. We have in Vuex, we get the state of the application. And if it has an address, we show one component. If it doesn't have an address, we show the other. But now, and the new look 2 years later, we have this huge container component that has over 160 lines of code. And while the pattern is still respected, we have dump components and one big container component. At the end, we cannot actually modify this file without being a tiny bit scared of what may happen, because this is used in a lot of places, not just here in the homepage. Another example is the store card. So when you go to Glovo, you go to the restaurants page and you want to order some food, you see a lot of the stores that we operate on. And this store card has basic information like the title, the image, some dynamic data like the rating, the delivery time, and so on. And it has some small variations if the store is closed, if we have Prime available, different types of small modifications CSS-wise. And this component has over 600 lines of code, this tiny component. And why? So we started small and we did A/B test after A/B test, and we added improvement after improvement while respecting the pattern. And this snowballed into like 600 or 700 lines of code. And every engineer has good intentions. Every PR has 2 or 3 more approvals. Every feature toggle looks innocent at the time. And you cannot argue that every addition improves the UX of the user, but it decreases the developer experience. Because when you have to code inside that component, it's very, very hard to read. It takes you half an hour just to realize what's happening. So how to avoid this type of thing? You have to keep your responsibilities clear. You have to break your big container into smaller smart components. And it's very good to apply this pattern on components that don't change often. Like us, this store card is a core business component of our application, and it changes every other 2 weeks. Whew. Another pattern that I'm going to talk about is the base variant pattern. This one is pretty simple in its design. You first create your base component, let's say a button. Then you wrap that button in another component to get a variant of the original. So if you want to create, for example, a danger button or an info button or a disable state button, that's what you do. You create your base component, you wrap it with another component to get a variant, and then you repeat this as many times as you need. As if you have many buttons in your application, you can use this pattern all over the place. But the important part is to always make sure that you encapsulate the core functionality of that button, because if you don't, things may get weird. And you can lose sight of what the button should be, right? You started off normal, a little bit different, and then you go into weird scenarios. And then you can go all over the place. In our application, we use this in all our dialogues and models. So we have one base model that has been created 2 years ago. And for every new dialogue or model, we just extend that base variation. So it's used in 46 models. All are lazy loaded. Last modification of this component was 6 months ago. So we know that we're not changing the basic logic. It's encapsulated and it never changes. And all of the variants have the same core. So when I'm talking about the core, I mean, when you click outside, what happens? It closes the model. When you click the X button, what happens? You have a title that's the same across all models. So this core functionality is present in every new component that you create. So a couple of rules to make sure you don't reach scary Terry level of Morty. Do not use the base component inside your application. Always use variants. Inside the base component, you have to isolate the core functionality, close for modification pattern. Prop control, once defined, do not add more props to your base component. That's what variants are for. And take advantage of slots to extend your component. And this pattern is very good for support components like models, buttons, and so forth. Am I going too fast? Factory pattern. This is very useful when you have to render a bunch of components and you don't know which, they're dynamic, so you don't know which component to render at a given time. So you delegate this functionality to a factory component that does this for you. So a quick example again from our application, our store page where you order food, it's entirely backend driven. So the server is giving us in the REST response when we go to /McDonald's, we ask the server for information. It not just gives us the data, it gives us what to render and where. So we have this response from the backend that says, hey, in the body, we have a list. In the list, we have elements. In the element, each element has a type. Is it a product? Is it a header? Is it everywhere? And inside the data, we have the props that we give to the component. So we loop through each of those elements, and based on the type, we create the component and we pass data as props. So this is how the response looks like, and this is how our code looks like. All that page is just this. An element factory, we loop through them, we have a type, and then we pass the data as props. Inside the factory component, again, it's very simple. We just use the view component is function, and we map the type to the type of components that we have in the application, and we just render them, passing the data as props. We lazy load all of these components so they don't increase the bundle size. And this is the element maps that we have. So we have a collection, a product, a carousel, a grid, image, list, and so on. What's very good for us, why did we do this, is we have, like I said before, an iOS app, an Android app, and web. And every time we want to change something in that page, we want consistency across all applications. So we don't want to make a deploy in the iOS app because that can take 3-4 days, while a deploy in the backend is very simple to do. So that's why we chose this approach. The downside is building this skeleton takes time, especially the backend. It's very hard to track when we use Google Analytics, stuff like that, because everything is on the backend. And we are making a lot of requests because each time you click a product, we re-render the page. We get the information again from the backend and we render the page. But the ability to have consistency across platforms was a big plus for us. Now, the composable pattern. This is like a mesh of the smart DOM components and the variants. Basically, it allows us to create layout components that encapsulate the visual output of the component. Then we have composables, which we use to extract reactive data, methods, computer properties, and reuse them between components. This is the view definition. And then we have renderless components that basically are a mix of layout and composables. So we can mix and match. It's how we create variants. So this is how we do. We create a different layout component for each use case. Then we go ahead and separate the logic into behavioral components. We choose either composables or renderless components, depending on the use case. And then we create wrapper container components as variations of this. I'm gonna give you an example later, but this is one of the downsides. This is what you get if you are not paying close attention. It's more popular in React that your React applications looks like this, but now in Vue is also possible. Performance is also a downside. You're rendering a lot of components. Each component has its own lifecycle methods, and it's not like rendering divs. This can hit your CPU. And increase the time to production, because if you have to do this for every new feature that you do, it's also very time consuming. Composables are also not native in Vue 2. You have to use a plugin for them to work. But yes, we try to use them on core features. Like I told you about the card, the core business feature that change every 2 weeks. Once we've done this for one component, it's very easy to modify and extend. So it gives us a lot of assurances that things are not going wrong. I'm going to give you a final example of this pattern that we implemented, bringing back the address component that we talked about earlier. It had 170 lines of code. We wanted to make, we realized at the product level, when we opened the homepage of our application, we had these two banners that were covering our address. So users, especially new users who didn't see that address there, didn't know that you have something to click. And the address is very important. If we don't know it, we don't know where to deliver. And our solution was, of course, to redesign this, make it smaller, beautiful, make it fit exactly in the middle of the screen. So it's the first thing that you see. So this is what we did. So we created variations. We created the layout component here, the white background with the heading. We created another variation without the white background, and we A/B tested them. We extracted the behavior from that 170 lines of code component, and we extracted into composables what happens when the users click the input button, what happens when they click the use current location button, what happens when you when you scroll past it, because we want it to be sticky, so the users see it at all times. And we've added, like, if you have an address, again, we extracted this into another composable component. And then we mix and match these two and created as many variations as possible and use them all over the application. A fun fact about this, we A/B tested this new feature and it failed. So people don't want to see the address as soon as possible. So yeah, thank you. In conclusion, I want to say that choose the pattern that fits the feature, composable for core features that change a lot, container presentation for general features, and base and variant for support components. Each pattern has its weakness. but you have to figure out where that middle ground is and what you're willing to give and take for any feature that comes along. From experience, it's really amazing to feature flag everything. They're like the hidden gem of development right now. Monitor critical business flows and A/B test to prove your assumptions. Thank you.